Later on, you'll be more interested in finding the distance between 2 points. But for eighth grade math, really, they will ask you a question like find the distance of this line segment. And at first, it seems odd, it seems different, but what happens is that you find out pretty quickly. You could actually sketch in a right triangle on this. So like if I sketched in a red line here and then go up, I made a right triangle. And then you could count up the sides of each one. You could see here there are two little squares um, sitting here. So 1 and 2, and then here it'd be 1, 2, 3, 4, 5, 6, 7. So you do that count, and then you know the length of each side of the right triangle. You know its leg length. So you know that the bottom would be 2 and the right one would be 7. You come over and use the Pythagorean theorem, plug in your legs, and it's right here that I want to mention. We haven't really discussed it before because I've not been with you in class, but we know what c is equal to. It's the square root of 53. There is no rounding there. That is the exact length. So you could say, well, that length right here. Let me get my icon out here to kind of point with. Um, this length is the square root of 53, which is a little bit more than 7. And we know that we can also find the square root of 53 and round it, and we could say it's about 7.3. So the answer would be the square root of 53 or 7.3, either one. Let me put this one down here. There we go. So it doesn't matter which one that you use, and if it's multiple choice, you kind of adapt to what they're using. If it's a worksheet or something for a professor or a teacher, then you just make sure you pay attention to the directions. Do they want you to round 7.3, or do they want the exact length, square root of 53? Okay. The other thing is that you don't have to draw that triangle to the right. You could also go up and you would see that you would have the exact same lengths. The legs would still be 7 and 2. So I just wanted to point that out. Okay, you could draw the triangle like that, or you could go back to the way we had it. Okay, so let's do one more. Let's go from the top point and go down and then over to the right. And once I count up the squares, it'd be 4 on that side and it would be 4 on this side. So the Pythagorean theorem is all set. We have legs that we can put in at 4 apiece. And how do we get the square off the c? By putting a square root on the other side. And that just tells me that the length, the distance between these 2 points is the square root of 32. Or we can go ahead and find the square root of 32 and round it. It's about 5.7. So either one of these would work. Okay. If you have any questions, please let me know. You might need to zoom in on the PDF so that way it's easier for you to see the distance here. You could sketch it out on paper if you wanted to, but really it shouldn't be too difficult to find the imaginary triangle you're having to build there and counts up the sides.